In this lesson, we will learn to work with the methods on our repository that allow us to retrieve instances of an entity from our data store. If we explore our book repository interface, you'll notice it extends the JPA repository interface. And in turn, that interface extends the paging and sorting repository, and that interface extends the CRUD repository interface. And the CRUD repository interface actually extends the repository interface, which is just a marker interface. The CRUD repository interface contains all of the methods that we will work with when persisting our entities. In this lesson, we are particularly interested in the find one method, as well as the find all method, and the find all method, which will accept a list of IDs. So let's close those interfaces. And before we are able to actually query for any entities, we need to add some entities into our data stores. So we need to put some records in there to return. So you'll see that we have this init.sql file, and it adds roughly 7 books into our H2 data store. Now, in order for this init.sql file to be executed, we need to configure a Hibernate property within our JPA properties. So I'm just going to duplicate one of the properties, and we'll change its key to the Hibernate HBM2DDL.import_files key. And this allows us to specify a file that should be ran after our DDL is created. So this is a great place to put our init.sql file, which will then populate our data store with the records that we have created. So I'm going to go ahead and close our configuration file, as well as our SQL file, and now our repository. And this will allow us to explore the retrieval methods on the repository interface. To get started, the first thing that we need to do within our application is pull the book repository bean from our Spring IOC container. So I'm going to declare a new object of type book repository that is named repository, and then I will invoke the getBean method on our context to pull the book repository bean from the Spring IOC container. And you see that I'm simply providing the type of that bean that I would like. With the repository pulled from the IOC container, we can now begin to retrieve our books from our data store. So I'm going to declare a book object, and then I will use the repository and its find one method to retrieve that book. Now the find one method just accepts an argument with the key of our entity. So in our instance, the book is keyed by a long, so we need to provide a long to the find one method that corresponds with the ID of the book we'd like to retrieve. So we're going to retrieve the book with the ID of 1. Next, I'm going to send that book to the console by just passing it to the system.out.println method, and we have implemented the toString method on the book object. So with this in place, we're going to run our application, and you'll see within our console output that we have printed out all of the fields on the book that corresponds with our toString implementation. And then you'll notice that we have this SQL that was executed on our behalf by the repository. And you'll notice that it includes a where predicate where it is inspecting the ID of the book and using that to discern which book should be returned. So now let's return to our application, and we're going to take a look at the find all method. The find all method is used to retrieve every entity instance within our data store. So we're going to pull every book record from our H2 embedded database. Because we're returning more than one book, we need to use a collection, and we'll change the name of our object to match that we are returning more than one book. So we'll go with books as our name. And if you look at the find all method, you see it returns a list of your entity. Now that we have this list of books that corresponds with every book in our data store, we will iterate through that book and print out the value of its fields so we can see what books we have returned from our data store. Now, you want to be careful. In our case, we only have 7 records. But could you imagine if we had, let's say, a whole college library here full of books, so maybe hundreds of thousands of books? We want to be careful when using the find all method in instances where there is a large set of records. So let's run this demonstration. We'll take a look at our console and see the output we get. So first, let's take a look at the SQL statement that was generated by our behalf. You notice that there is no longer that predicate or that where clause, which is going to discriminate against which books are returned. Instead, we are returned every book within our data store as we expected. Now let's look at one final method on the repository interface, and that is the find all method that accepts an iterable of all of the IDs that we would like to see returned for each book. So we're going to pass in a collection of IDs, and the find all method is going to return all of the books that have IDs matching those in our collection. So in a sense, we're not really finding all, we're being a little bit more picky about what we're returning. So to do this, I'm going to pass an array list of longs to our find all method. And I'm going to use double brace notation to construct our array list. It's a nice concise way of building out a list. And we'll pull back the book with the ID of 1, the book with the ID of 3, and the book with the ID of 7. So we should only get 3 books this time. And you'll notice that we're going to get some complaints regarding not adding the serialized ID to our list. We don't have to worry about that. That's more of an Eclipse issue. So by passing in this collection of IDs to the find all method, we're able to retrieve multiple books, but at the same time, we're able to specify which books we'd like to retrieve. So let's go ahead and run this example, and we'll inspect our console output. And you see that we have indeed received 3 books back. And if we inspect the generated SQL, you see that Spring Data has now used an in clause in order to selectively choose the records that we would like to see returned. You'll notice there is a parameter for each of the 3 values we provided. So that's Spring Data in action. It's customizing that SQL we're executing against our data store, and we're not doing any of that work. We did not write any SQL. The Spring Data project performed all of the work for us that was required to retrieve our entity instances.